Welcome to a video on determining the equation of a polynomial function where the roots are given. Consider example 3. Find a formula for p of x if the function is of degree 4 and has a root of multiplicity 2 at x equals 3 and roots of multiplicity 1 at x equals 0 and x equals -3 and passes through the point 5 followed by 16. So let's start with the p of x notation. We want a fourth degree function, so let's call the leading coefficient the value a times x to the power of 4, and so on. So this is the leading term of the function that we're looking for. We'll try to express this in factor form since the roots are given. So p of x is equal to a times, since the first root x equals 3 has a multiplicity of 2, then x minus that root raised to the second power is a factor of the function. Likewise, if x equals 0 is a root, then x minus 0 is a factor of the function. Its multiplicity is 1, so we can just simply raise that to the first power. The same goes for the root of -3. So x minus that number is a factor of the function as well. Again, raised to the first power due to the multiplicity of 1. Now, if we multiply these factors out, in other words, expand them out, we would end up with a fourth degree function, which is exactly what the question is asking for. The only problem is we do not know the leading coefficient. To find that coefficient, we're going to use the fact that it has a solution point at 5 followed by 16. So if this is a solution point, it's an ordered pair that will satisfy the polynomial statement, making it true. So we're going to replace p of x as 16, that's the y value, and then replace x here with the input value of 5. So 5 minus 3 quantity squared, 5 minus 0, 5, these two negatives, let's combine them as a positive. So 5 plus 3 as the last factor of the function. Now we can solve for a. So simplifying this, we get 2 squared, which is 4. 5 minus 0 is 5, and 5 plus 3 there is 8. Hence, on the right-hand side of the equation, we have the product of 4, 5, and 8, and a. So that's 20 times 8, which is 160. And don't forget the factor a as well. And now we can divide the equation by 160 on both sides to solve for a. So reducing this, we get 1/10 as the coefficient of the function. So the polynomial function p of x in factored form is 1/10 times x minus 3 quantity squared times x plus 3. We can leave it in this form or expand it out depending on how the question is worded. So in this particular case, it didn't ask the function to be expressed in a specific form, so I'll just leave it as factored form.